right, let's take a look at this last problem, number 7. The mean number of minutes for app engagement by a tablet user is 8.2 minutes. Suppose the standard deviation is 1 minute. Sample size is 70. So again, similar to another problem that we did, only this is with CLT for sums. So it says, what are the mean and standard deviation for the sums? So first, we'll write down all the information that we have. Then we can go ahead and we know the mean for the sums is n times mu, which is 70 times 8.2, which I already did the math ahead of time, was 574 minutes. The standard deviation for the sums is the square root of n times the standard deviation, which is the square root of 70 times 1, which is 8.37 minutes. B says, find the 90th percentile for the sum of the sample. Interpret this value in a complete sentence. So we're going to let K equal the 95th percentile, and we are going to do the inverse norm with 0.95, comma, we'll use our values up here, 574, comma, 8.37. And let's just see what we get here with this calculation. Inverse norm 0.95, comma, 574, comma, 8.37. I get 587.77. So what does this tell us? This tells us that 95% of the app engagement times are less than 587.77 minutes. Now that's the sum. Remember, we're talking about the sum here. C says, find the probability that the sum of the sample is at least 10 hours. Now, we should have red flag, red flag, red flag here, because all of our other data is in minutes, and this is in hours. So the first thing we are going to do is do 10 hours and convert that to minutes. 60 minutes in an hour leaves us with 600 minutes. Okay, so that's our sample, 600 minutes. Now that we have that, we want to find the probability that it's at least 10 hours. At least, so greater than or equal to 600 minutes. We're going to use the normal CDF. 600 is our lower value. E to the 99 is our upper value, 574, comma, 8.37. So let's go ahead and put this in our calculator. Second distribution down to normal CDF, 600, comma, e to the 99, comma, 574, comma, 8.37, close parentheses. And I want you to take a look at this answer. The answer is in scientific notation. So let me just quickly tell you what this means. 47, let's see, let's say 2. So the e to the negative 4 is the same thing as writing times 10 to the negative 4, which basically means, I'm going to write this down here, like this, basically means negative 4 means you're going to move the decimal place 4 places to the left. 1, 2, 3, 4. Okay, so our answer, this is our decimal as a percent as a decimal. So if we want to change 0.009472 to a percent, we always move the decimal place 2 places to the right, or you can take your answer and times it by 100, and we get 0.0947% probability that the sum of the sample is at least 10 hours. It's a very, 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 very tiny percent chance that the sum of the sample is at least 10 hours.